Building a rocket isn't a walk in the park. There's a good reason behind the saying, it's not rocket science, because, well, rocket science is tough and expensive. As expensive as rockets are, it's surprising to think that until SpaceX came around, we were using them in ways that weren't the most cost-effective. For a long time, one of the biggest mistakes was using these pricey machines just once and then discarding them. After they were used, large parts of them, like the boosters, were left to float in space or fall into the sea. This was not just wasteful, but also very costly. Imagine buying a car, using it once, and then throwing it away. That's how rockets worked. Every part of a rocket, even the smallest bolt, costs a lot. If you add up these costs, a rocket's price can be in the hundreds of millions of dollars. Take the Space Shuttle, one of NASA's most iconic vehicles. Each launch of the Space Shuttle cost about $450 million. A significant part of that cost was the shuttle's solid rocket boosters. These boosters played a critical role in lifting the shuttle off the ground and propelling it into space. Once their job was done, about 2 minutes into the flight, they'd be jettisoned and parachute into the ocean, where they were later retrieved by ships. NASA did have a partial reusability concept here, as these boosters were refurbished and used for multiple flights. However, the refurbishment process wasn't cheap or simple. It involved inspecting, cleaning, and often replacing various parts of the boosters. Now let's imagine a hypothetical scenario where the boosters could land themselves safely on land, ready for quick reuse, similar to what SpaceX is doing with its Falcon family rockets. If such a system reduced the refurbishment costs by half, then, considering the boosters alone, NASA might have saved approximately $30 million per launch. Over the course of 135 shuttle missions, if NASA could have halved the refurbishment costs for the boosters, the savings could have been as much as $4 billion just from that component alone. Of course, this is a simplified and hypothetical calculation, but it gives a sense of the potential savings when rocket components are designed for rapid and efficient reusability. This is where SpaceX comes in. When SpaceX first began, big and old companies, some even backed by entire governments, controlled the space industry. These giants, like NASA and Boeing, had been doing things their way for decades. For SpaceX to compete and survive, doing the same old thing wouldn't work, especially because they didn't have as much money. They needed a fresh idea that would set them apart. That's when they thought about making rockets reusable. At first, many people laughed at this idea. They thought, if this was possible, why haven't the big companies done it already? But there's a catch. Big organizations like NASA get money from the government, so they don't always have to worry about saving costs like a regular company would. Their focus, especially during times like the Cold War, was more about showing off their power rather than saving money. On the other hand, SpaceX was different. They were a new company and they didn't have endless money. They had to think smart and save where they could. Through countless tests, SpaceX began to achieve what many deemed impossible. Their Falcon rockets not only reached space but managed to return, landing vertically in a spectacle that looked like something out of a sci-fi movie. SpaceX then came out with an even bigger idea. Why not land rockets on ships in the ocean? When a rocket goes to space and comes back, it uses a lot of fuel. If the rocket tries to fly all the way back to where it started, it'll need even more fuel. And if a rocket carries more fuel, it can't carry as much of other stuff to space. SpaceX didn't get it right the first few times, but over time they mastered the process. Today they efficiently operate 4 active drone ships for their launches. Now when we come to everyone's favorite rocket, the Starship, it's important to note that it's not just another Falcon 9. Starship is a 120-meter tall rocket, the largest rocket ever to be created by humans. Given its unprecedented size and ambitions, it's not surprising that SpaceX needed a totally different approach for its reusability. Enter Mechazilla. The idea behind Mechazilla is as futuristic as the name suggests. Instead of letting Starship land in the traditional sense, SpaceX is exploring the idea of having giant catching arms or mechanisms that would quite literally catch the rocket booster as it comes back to Earth, before it even touches the ground. Imagine a giant robotic hand reaching up and grabbing the rocket out of the sky, ensuring a safe and precise landing. Yet, when we look at the upcoming second launch of the Starship, SpaceX seems to be taking a different approach. They won't be employing the Mechazilla for this launch. The whole journey, set to take around 90 minutes, will start from Starbase and have the rocket soar over the Gulf of Mexico, navigating between the Straits of Florida, and then ending near Hawaii. Despite the fact that both the Super Heavy and Starship are engineered for full reusability, this mission will be the lone flight for Booster 9 and Ship 25. Rather than the iconic vertical-powered landings we've become accustomed to seeing on solid ground or a drone ship, these rockets will splash down into the ocean. Booster 9, powered by its 33 Raptor engines, will operate for about 169 seconds into the flight. Then it'll part ways with Ship 25, and just 3 seconds later it will reignite some of its engines to guide it back towards Texas. The intended splashdown zone? Roughly 20 miles off the Texas coast in the Gulf of Mexico, about 8 minutes post-launch. Ship 25 will ignite its 6 Raptor engines roughly 3 minutes into the journey, propelling it eastward. These engines will keep roaring for about 6.5 minutes. Interestingly, while Ship 25 won't complete a full Earth orbit, it will aim to get close to an orbital velocity, which for a low Earth orbit stands at a whopping 17,500 miles per hour. At its peak, if all goes as planned, it'll be soaring at an altitude of about 150 miles. Then comes the crucial part: a high-velocity re-entry into Earth's atmosphere, a true test of Starship's design and engineering. The goal is a splashdown around 62 miles off Kauai in Hawaii. This entire sequence, from liftoff to splashdown, is anticipated to be wrapped up in a concise 90 minutes. Why is SpaceX doing things differently this time? Well, it's not just for show. They're running this test flight to collect important information. They want to learn and make their Starship rocket even better. Every detail they get from this flight will help them improve and change the future of space trips. That's all for today's video, folks. If you enjoyed watching and found it useful, please make sure to hit the like and subscribe button for more similar content. Thanks for watching, and I'll see you in the next video.